spruce thinnings, but kind of reverse the structural action, so forming a compression structure out of these pieces. So those are lots of wrapped pieces of spruce, kind of wrapped to keep the moisture content high. And then one by one, these were pulled kind of manually down into a series of arches, which form this kind of barrel structure. You can see there. So quite kind of extreme in a way, as a way of taking small bits of tree trunk and forming an enclosure out of them. And that's a space where we spend a lot of our time. So the workshop space and actually the studio and the office space is in the last bay of this building, beyond that wall. The third building was a few years later. An architect, Ted Cullinan, London architect, designed and built this dormitory building. So there's kind of 8 rooms in there. Again, it's using material directly from the woodland. And I guess they all kind of embody that principle of using a local material, and also in slightly sort of various ways, mechanisms through which the designer was involved in the making. So in the prototype house, and that first building, the project architect actually became the builder. He spent the summer on site, and he's actually involved a bit now again at Hooke Park. He's a really good guy, William Morwood. I don't know, the lodge was actually built partly by Charlie, who now runs our workshop. There's kind of anecdotes anyway, which maybe just slightly inform what we talk about later about how the maker became kind of part of the design process. There's an anecdote about the workshop as well. So when these pieces were being pulled down, I think the engineers, Buer Happold, described this very explicit kind of predetermined process where with a kind of with ratchets, whatever, that these pieces would be pulled down following a rule every day by a certain amount, and they kept snapping them, and it was impossible to kind of get the building to come together. And the guys building it were like, well, if we just pull it, we can kind of tell how far we can pull this piece of wood. And as soon as they kind of allowed that to happen, it just kind of worked out. Just the human intuition about what a piece of wood can do, done by the guys who do it every day, brought suddenly a layer of kind of, I suppose, tacit knowledge to delivering this project that you wouldn't get in a kind of conventional workflow of someone designing something, drawing it out, specifying it, and passing it on to someone to build it. So there's kind of lessons already in these buildings that kind of reflect back, I suppose, to the premise of design and make, which is that the making and the design should be integrated, that the interaction, that the feedback between those two things kind of opens up new possibilities that you wouldn't be able to do sort of conventionally. Anyway, right, where did we get to? So the Parnham School closed down late 90s, the place kind of went dormant. Then the AA took over in 2002, with the campus sort of looking like this. So a windstorm had kind of cleared out some of those trees you saw in that earlier photo. You can see the 3 buildings I've been talking about. A little spot where the sawmill sits now, that project is up there. That's more or less what the AA inherited. So the Google view from then, more or less. And more or less how it looks now. So the AA inherited the place, but also a planning permission to expand the campus. A larger campus had been anticipated, as well as, I suppose, that kind of agenda we've been talking about, and some very key people as well. So the forester who'd been involved from the outset with the Parnham team stayed on. Chris, so he's I just had an email from him now wanting to know what's going on with the next project. Charlie, who I mentioned as well, who runs a workshop. So it's kind of an inherited set of material and kind of knowledge, which the AA, had the luck to take on. So fast forwarding a few years, so I suppose the way the AA uses it, there's kind of 3 activities that happen there. London-based students go out with their tutors and do short visits. They can stay on site and kind of do things in the woods, long weekends up to a couple of weeks. In the academic breaks, we run visiting schools, short courses, kind of within the AA program there. And then the thing that I'm most heavily involved in is the design and make course that's based at Hooke Park. So that's 16-month MArch, so post 5-year study master students and MSc students who have a sort of broader range of intake, spending time designing and building at Hooke. So we established that in 2010, and then we've been building our own facility kind of as we go along. So the first thing we took on was the big shed, the big thing in the distance, to basically give us a big kind of mothership and assembly workshop space to then be able to timber frame and prototype and do the things that we've done since. So I'll talk about a couple of these things in detail. through the class, but just to kind of give you a sense of the overall. And I guess it's kind of a parallel talk more about the houses and some of those projects. So there was a caretaker's house we did, and a couple of lodges, which in the long term will be for student accommodation use. Right, I'm going to kind of park Hooke Park there a bit and kind of rewind my life a little bit, and just a sort of route through a few projects that informed, I guess, how we ended up doing what we're doing at Hooke Park, if that makes sense. So I guess, as Michael mentioned, I studied aerospace engineering. I worked a bit at Airbus, and then ended up kind of intrigued by architecture and worked at Arup, the big engineering consultancy in London, doing kind of curious mix of things. Generally stayed clear of conventional buildings and was able to kind of do the fun bits, which is great. The guy Cecil Bauman set up a group called the Advanced Geometry Unit in the early 2000s, which kind of put us as young engineers in a very privileged position of working with an amazing list of architects at that time. So we had some fun back then. And one of the projects I was, I guess, most heavily involved in was this one, which was the I think I put the title of it there, the Serpentine Pavilion that was by Caesar and Demora with Cecil in 2005. So, I mean, there's a whole lecture in this, I guess, but I think the word that was kind of coined between those people, between Caesar and Cecil, was a kind of contemporary vernacular. So they looked at some of the kind of tectonic, I suppose, of English framing techniques, the sort of half timber houses, kind of developed that into a bit of a kind of animalistic idea that came from Caesar and Demore, and then we kind of went down this route of developing a kind of reciprocal arrangement, a kind of a grillage system that allowed lots of these LVL planks to form this freeform roof. And we cut it with a robot at the time, which I think, kind of looking back, was quite an interesting moment. I guess at the time it was like, how do we make this all, Merck have a robot, let's kind of do it through that. But sort of looking back, I guess it's quite formative for us that we'd thought through a project that deployed that robot. I mean, nothing like what, obviously many people are doing, the sophistication that people are working with it now, but it did allow us to cut, kind of full three-dimensional geometries into these planks. I guess particularly the top edge, which you probably can't quite see in there, but the top edge, to kind of give a smooth surface for the cladding to sit on, has a kind of twisted profile cut along the top that allowed each piece to meet perfectly through it. So anyway, there's kind of a lesson there. And at the time I'd started teaching with Charles Walker on a unit that he'd set up, which I guess the original premise was to kind of parallel the Serpentine Pavilion projects, and each student would design their own Serpentine Pavilion and kind of take it to a sort of construction detail. But then I joined, and we actually turned it into a design build pavilion unit. So we kind of took the Serpentine model a bit. We actually stole the sponsor, so the firm who'd provided the material sponsor for this building, we then persuaded them to sponsor an AA student built pavilion, which was an amazing support from them, from FinFast. So we ran that program for 4 years. So there was a series of 4 of these things that undergrad students, so second and third year students, designed and built. It was through a year-long program, so we kind of, I guess, had a sort of skills and ideas first term, and then proceeded with a few of the possibilities, kind of had competitions to kind of narrow it down, and then ended up with one piece that would detail in London, and then would go to Hooke Park. So already we were kind of working at Hooke Park for 5 weeks to build these things. So I just run through these things quickly because they're kind of fun. So Simon Whittle in the first year, I mean, these kind of explorations, deliberately kind of abstracted and playing with very kind of crude sort of scripting. This is pre-Grasshopper, so it was kind of Excel scripts and that kind of thing to explore some geometric ideas. He proposes fractal geometry. I've just realised now, actually looking back at this, the reference to the natural geometry of the tree, which kind of comes in again later. And I suppose it was an exercise, like we cut away a lot of the conventional concerns of architectural education, I suppose, on the basis that these were students doing this for 1 year after a 5-year education, focused hard on the process of delivering a project like this. So, these are the bunch of students, here thinking about how to make the jigs to make all of these pieces. Nayar on the right actually was the jig girl. I think she was a teenager, at the time. She's now actually teaching urbanism at the AA now, so I'm not sure what the jig work, whether that was formative or not, but anyway, she had fun. So I suppose running through this was a sort of a kind of pedagogic argument that we were exploiting that kind of that tactile engagement. I guess that sort of phenomenological argument that you actually learn through doing. You learn through your body, that you can't abstractly kind of formalize and understand and learn everything that way. You have to kind of go through a cycle of abstractly thinking about it, and then in some way kind of making it concrete, understanding how you're actually realizing it. I guess there's a couple of quotes that kind of back that up. When a word is deprived of its dimension of action, reflection automatically suffers as well. The word is changed into idle chatter, into verbalism, into an alienated and alienating blah. I think just the need, the physical need to kind of something like this just to get these pieces to slot together. The kind of physical engagement was very clear. You're building kind of pavilion scale work. Quotes from Sennett, I'm so you're probably familiar with this, kind of arguing for the value of craftsmanship, of a kind of consideration of how you actually engage with material. Motivation coming from the drive for metamorphosis, the drive to change form. So we maxed out the workshop, made lots of pieces, worked out how to get them to London, and then with some professional help, put these things together in Bedford Square. So that was the first one, the 2006 pavilion. There's a sequence, I'll just kind of rattle through them. So there's one that was titled Bad Hair, slightly silly, but there's some nice moments in this one, these doubly curved glue lamp pieces where we kind of, I guess we worked out a method which kept that square section by CNC cutting each layer of the lamination slightly differently to kind of maintain that shape. So that was that thing. The third one, the swoosh pavilion, it's the kind of early ideas, exploring some of these patterns. Again, a kind of a CNC, and I think these guys coined the term manual scripting, which is kind of, I don't know, turning it back, I suppose, to the reality that you don't just, like, these things are never just done by going through a digital design and production workflow. You never just kind of design something and press print. There's always going to be a whole lot of things you think about when the actual realities of the thickness of material, what the tools can do, how heavy things are, how the timber behaves, all those factors come into play. So that was that one. And the last of these was sort of a kind of field conditions sort of vector script that was quite fun, that sort of led to kind of references of driftwood and a few ideas that came through as the kind of winning idea. I think this one had a bit of a cheat, and it had a kind of internal framework. It's a young version of me. But kind of a interesting exercise how to generate this very kind of organic form in a way that you could actually describe and organize and keep track of. So lots of sheets of plywood, lots of CNC work, lots of exercise to kind of build this multi-layered object. The elevation of the plan, kind of interestingly different. The students with pieces of wood emerging, and the objects that's there. I think at this moment, this was the last of the pavilions we did, and I know, for a while I think Charles had been kind of struggling a bit with the agenda of the programme and kind of what we were doing, and I think there was a few ironies in there that were quite extreme. One of them was we were using Finnish spruce in a plywood format, some of which was being sent to Austria and then sent to Hooke Park. So our sponsor kind of, obviously we were using their material, but the just the irony that we were based in Hooke Park in this place, the whole conception of it was that it was intended to use the immediate local material, and we were importing spruce timber from 1,000 miles away or something. So I think there's something there to kind of address. And I guess another one was just this irony of kind of going through a workflow where something natural is being cut down, sliced up, glued back together, made into some kind of rectangular, cuboid product, moved around, and then go through all of this effort to basically turn it back to something with organic qualities. So I don't know, there's that kind of question thrown up there as well. That was a piece of wood Zach, one of the tutors, pulled out of the woods a few weeks ago, just as a kind of, I don't know, somehow to kind of link, just as an interesting piece of found, inherent form material, which we can 3D scan, we can take to get an amazing degree of detail from. Not sure what we'll do with that piece of wood, but just to prompt that idea that there's a way of thinking about material that isn't this industrialized product basis. Okay, so I'll run through some design and make work. I was just going to show another little video, just as a little break. This one is it's a bit of a kind of promo film, I suppose. It's just to kind of give a bit of an overview of the design and make kind of realm and how we work and what we do. I'll talk briefly about the big shed, which is the first of the design and make projects. Kind of a one-off because of its scale. It's a big, 500 square meter building, delivered with a lot of timber framing help. It wasn't entirely done by students, something on that scale, but I guess the whole design process, the thinking and the prototyping, they're kind of working through, and just the follow through was with students. That's Nozomi, who is the first design and make graduate in that very first cohort. So I suppose the starting point is similar to any other project, isn't it? Sketching, model making, thinking something through. But I guess in parallel, these kind of things are going on. A sort of deliberately bad photo in a way, but just showing these kind of like people standing in the woods, stroking their chin, kind of thinking, okay, In this case, we had a need to fell a whole load of our larch because the larch disease was spreading through. There was kind of a sort of sanitary felling, a need to kind of take out the tree that might get diseased. So there was a prompt to kind of think through how we could use that material. Quite early on, we built that, which, was a shock. You suddenly think, okay, we're going to build a large span building out of this stuff. What does it mean to start assembling pieces of wood on that scale? How do we make those kind of connections? And immediately, this was early in the design process, just thinking through how we'd make a big truss out of this material. And a lot of feedback and extraction, thinking and refinement about the reality of actually using that wood. So again, it's round wood. It's kind of back. I suppose it is casting back to some of those early ideas. Like the woodland had grown up since the 1980s, so using those small diameter poles was no longer an option because they're now 20 years older. So different approaches how to actually work with a lot of the traditional timber framing techniques for how you work with roundwood poles, how you strike center lines, how you actually set out, and quite manual processes for getting control of the material, and then working through basically connecting these things together. We worked with Atelier 1 as the engineer and did quite a lot of load testing and work with Bath University. Developed a system of connecting these things with Hiko screws, just like really massive screws that kind of gave us a lot of the timber to timber connections. So there's a bit of kind of research going on in there. Basically it was a series of these trusses made flat, as you can kind of see there, and then lifted up into to form the building envelope, and then an exercise of making lots of cladding cassettes that got lifted on and formed this space. So you basically use it every day as the kind of assembly workshop space. There's a big door that can open up, you can move things in and out. You probably saw it a bit in the video there. And it houses the robot, so we just have the one KUKA, initially with a spindle router on it. We've kind of tooled up a bit more now with some chainsaw and bandsaw experiments, but just a space, the robot, the KUKA, and the ability to bring pieces of material to that. Skip that one. Okay, so that was kind of an exercise in, I suppose, getting a head's background using Hooke Park material, doing it on a big scale. I suppose whereas the earlier buildings had all used material and sort of bent it elastically into a shape, into a tension shape, the compression shape, the dormitory as well kind of did that. This is, using these big pieces as kind of straight elements in the truss. Basically, we didn't have thin bits of wood to bend in that same way as those early projects. This was a couple of years later, so the seasoning shelter project became an exercise in using the wood plastically. So rather than kind of bending something elastically, using steam bending as a technique to give a permanent deformation to the piece of wood. So I guess a few things fed into this. Here's another picture of people standing around looking at a tree, but it's so important, So with the foresters, Megan, one of the students, a beech tree needed to be thinned, kind of thinking through, okay, there's this amazing, semi-mature hardwood that we basically can only sell as firewood. Surely we can do something better. The students have spent time with the furniture maker locally and got very kind of excited with the poetry of steam bending. So a whole load of exercises kind of building up a knowledge of how you take a piece of wood, steam it, and the limits of what you can do to bend it. This is Omri, who went on to have a career as a steam bender, kind of. So developing steam bending jigs that allow different shaped pieces to be made, discussions about how to combine those, again a bit of a kind of reciprocal structure. So each of these pairs of steam bent pieces become little trusses that all kind of slot together in the overall structure. The final steam bending jig, so a big, there's like an overhead projector that would project the required shape of each piece, a bit of manual adjustment to these blocks, and then each of these pairs, all different, bespoke pieces made and screwed together. And it's quite a process. So there's this jig and then another jig to do the fixing of them together to kind of make sure all the shapes were kept correct. And then an exercise, again, kind of physical manual exercise, how to bring these pieces together into patches. So the sequence of combining these pieces into these curved patches, and then bringing them together on site, craning them in, and then there's the finished thing. So the wrapped shelter. So basically just a rain shelter to keep to keep rain off air drying stacks of timber. And I guess an exercise in geometry and the structural logic of that. The following year, we kind of jumped again into a different strategy of bringing curved elements into the building. So we kind of talked about elastic deforming it, plastic deforming it. The strategy here was to take the inherent curve of pieces of wood from Hooke Park and put them in the building. So there's a whole patch of trees on a slope where the trees had grown. I think when they were young, the undergrowth had meant that they kind of went out horizontally to find the sun and then went up. So hundreds of trees like this, which to a forester are a disaster. They've got negative value. You can't really move them. You can't drag them out of the woods because they all get snagged up. You can't load them on a truck. You can't put them through a chipper. That curve is basically for a conventional forester who wants tall straight trees is a disaster. But to us, I guess, who are kind of interested in how material ultimately makes space and how that's interesting to us, the fact that it has this inherent geometry was of interest. So the pretty simple exercise, going out, just a $30 second-hand Xbox Connect scanner, a laptop, a couple of students out in the wood cataloguing these trees, little script that would just take that one scanned face and just fit a series of circles, approximate it, some diameter, get some diameter and taper and centerline data, and that was enough to kind of bring that whole catalogue of those, a few hundred of those, through a design cycle digitally, finding ways of, again, little scripts that would kind of assemble them, step them, layer them up, that would control the differences between each layer and give kind of sculptural qualities that were of interest. So taking the direct geometry in. I guess another sort of interest or agenda is like the ability to, I suppose, sort of hack the tools. So taking an electric chainsaw, mounting it in a trolley as a way of taking a consistent horizontal slice through a piece of wood. So these things have their kind of varying form one direction, but we wanted there to be consistency the other way so we could stack them. So finding ways of developing those kind of bespoke tools. And then the piece, so stacking these elements and allowing them to take their form in the building. I mean, I think this, it was a little kind of hint, I suppose, as an idea. Like, it doesn't very radically exploit the qualities of that. It's basically a, kind of a log, traditional log construction, but distorted. But it did prompt the next project, the wood chip barn. So this is the last one I'm going to talk about. This is the exercise. Kind of, there's a hint in the title there, the tree fork truss. So I suppose taking that kind of argument further, we live in this kind of industrialized age, this paradigm of, kind of expecting our building materials just to come from somewhere. You buy them from somewhere, you order them, they get delivered on a lorry. Their provenance generally isn't of that much concern. I guess with wood, it has a stamp saying it's kind of accredited in the right way or something. It's not come from a protected woodland or something, but it's it's kind of symptomatic, I guess, that we are detached from our sources of material. So I suppose to look for the opportunities of finding arguments for using what you have locally and kind of approaching that in a different way with the technology available seems like a kind of a valid exercise. Anyway, there's a tree from near us, kind of the character you have. I guess there is a historic precedent for this. So I think this is French shipbuilders. I guess there's a parallel, probably competing exercise with the Tudor shipbuilders in England, where they would deliberately partly train trees, or at least survey them, oak trees generally, to anticipate their use in these big timber-built warships, from the 16th century, 17th century. And I think there's records of a cataloguing. There's a woodland that still exists called the New Forest, which is very old in the south of England, where there was like 20,000 oak trees catalogued in this way, anticipating the use of their geometry in the ships. Anyway, those beech trees that we've been talking about, most of them split somewhere up their trunk. So you get a section of the tree, which again is a disaster for the forester. It's difficult to do things with a piece of wood like that. But I suppose we, the students, kind of saw, the potential not only to use the geometry, but to use the inherent structural capacity of a piece of wood like that. So trees have evolved to resist wind and snow load, and to cantilever these branches out. Huge span to depth ratios. And in that joint, there's a system of interlocking of the grain that's very, complex, not really understood. There's papers about it, but there's stuff that goes on there which has evolved to kind of generate this very strong existing structural connection. Generally, when you design with timber, the very first thing as an engineer you learn if you're designing with timber is you design the connections first, because they always are kind of the critical bit of a timber structure. Different to steel, where if you design the section, it kind of works at the connections. With timbers, you always have to basically over-design the connections to make it work, because it's so hard to get the forces out of one set of grain through some kind of connecting hardware and back into another set of grain. So if you have a ready-made natural connection, the potential of using that becomes exciting. I guess part of that argument is kind of captured by that. So I suppose casting back to what I was saying a bit about the pavilions and kind of taking rectangular product, adding geometry to it, basically the redundancy of taking something non-standard, standardizing it, and then doing our kind of mass customization kind of stuff that everybody talks about with these tools. The redundancy of that, I guess, to challenge that, to go directly from the non-standard material to the non-standard components. The exercise. So this is the object, I guess, the truss. So it's a 25-meter span, kind of end-to-end arch. You can see the geometry there, composed of 20 of these tree forks. The view from above, the view from below. Get the idea. Okay, so we'll talk through the process of this. Diagram to show the brief. So it's pretty simple. It's to shelter basically a 1.5 year supply of wood chips. So that boiler house project I showed, the one with the curved pieces, that houses a biomass boiler that provides heat energy to the whole campus. So the hot water and the central heating. And the premise is that we will fuel it. We are now fueling it with the kind of forestry byproduct and trees that come out of the woodland. So this is the barn is to store that wood chip between felling and chipping it and actually using it. I guess that was kind of the starting point. So again, what to do with these pieces. Quite a painful period, I guess. I mean, it's a question to the students. There's this idea. They'd kind of bought into this starting point, how we actually configure that kind of component in a meaningful structure. Lots of kind of models and ideas, and a lot of doing this with your hands, trying to work out configurations that made sense. Working closely with Arup. So there's an engineer at Arup in London, the engineering firm, called Francis Archer, who works closely with us, and he has a team of engineers who kind of get involved. Nice exercise for them to get involved with our projects. Anyway, as that thinking was going on, I guess in parallel we kind of got out there and did a survey of the forks. So there was an iPhone app that would measure the inclination of your photo, and then a little script that would correct that back to the true geometry of the piece. So the students generated a catalogue of all the forks they could find, which kind of gave us a starting point in the discussion with the engineer. This is the kind of range of size of fork that we could deploy in the building. Various ways of kind of analysing that, the different diameters and angles and characters of the pieces of wood. And I guess a sort of filtering down into the pieces that felt most useful, and also the pieces that the forester would be happy to extract, because it's always a negotiation, I guess, with the forester. We have to kind of work in parallel with the forest management processes that are going on. Anyway, a bunch of those. And then I suppose it's that kind of underlying of that form of the arch emerged as a kind of possibility, and sort of testing to see that those 2D scanned shapes would configure into this arch that was being proposed. So it's kind of an iterative exercise to reach that point. The third scale prototype, just to kind of get our heads around the idea of using these Y-shaped elements, basically with the original trunk of the tree as the kind of lower chords of this triangular section arch, and then separate pieces forming the top chord. A complex kind of series of grasshopper operations the students set up to kind of work through basically a kind of optimization process to determine where those forks would be best placed. I'll talk about that in a minute. Right, another video to wake people up again. This is kind of a 2-3 minute video that just captures the sort of workflow process of that project. So I'll show that, and then I'll talk through some moments of that in a bit more detail. Idea. So, working with forks. So step one, someone goes out with a chainsaw. So that I think the students photographed maybe 170 of those forks, and then we narrowed it down to a short list of 25 that seemed most likely to be used, out of which we used 20. There was a very crude initial load test, which was basically if the tree hit the ground and that happened, you knew you didn't have a good fork. So there was, we did find some of the forks had this kind of sort of intrusion into the branching point, which wasn't good news. So through kind of this and inspecting them, we kind of made sure we had good ones, drive them out, bring them to the yard, debark them, always fun, and then a detailed 3D scanning exercise. So photogrammetry exercise, that's where you take lots of still photos. Software like Agisoft allows you to then compose the 3D mesh. there's a few strategies which we kind of anticipated. So right then we had it doesn't appear in that picture, but we had a little, basically a referencing point jig. So it was a little metal frame that basically drilled one point, another point exactly 1.5 meters away, and a third point then I think some dimension away. So basically three points that would be drilled to a certain depth, and we had a little kind of marker piece. So in the initial 3D scan, we knew where those 3 points were. So we had a kind of local access system already kind of known for that piece of wood, which became useful later. So we scanned all those forks, lots of meshes like that came out. So pretty detailed, not super precise, I guess. Photogrammetry is, it's scaleless, so it's a little bit tricky to know that you've got the dimensions spot on. But you can kind of deal with that, I suppose. There was the kind of target geometry, so developed with the engineers, kind of form found, idealized compression structure. So the target center lines of the chord lines for the pieces, and an exercise in basically matching elements to that target. So it's a bit like what I showed for the bent pieces, able to kind of define kind of center curve for these pieces, some key nodes, and then basically place, so through a script, through Grasshopper, placing these Y shapes on the curves. And something's kind of worked in our favor, like when you have one of those Y-shaped pieces, the trunk would tend to kink a little bit one way when the branch went off the other way. So that little diversion kind of worked quite well to match the main curve of the arch, if that makes sense. And then we'd use the branch piece to go off and catch the top chord. So the geometry worked quite well to kind of match things. You can maybe sort of see what I'm describing, kind of along that line there. It's a bit hard to pick out, but the slight kink in the fork that you get, the angle kind of between that piece and that piece, would kind of work as a sort of facet angle along the chord. So there's quite an exercise one of the students took on who used some of the evolutionary solvers as Grasshopper plugins, Galapagos, some of those plugins, to sort of drive a series of exercises to try and help find the best position of where these forks would go. And it was quite a subtle challenge because you had to, obviously your sort of starting set, you deplete the available pieces as you went along. So there was a kind of exercise in doing it once and then seeing which bits performed least well structurally, and then prioritizing those in the next iteration of the optimization. So you would fill the more critical points with the pieces first, if that makes sense. So it was kind of a sort of nested iteration of optimization, where you would rerun the optimization sequence according to which pieces needed the best pieces first. Anyway, there's a whole kind of story around that. We did actually present at the Advancing Architectural Geometry conference last summer at ETH. We presented a paper kind of on that, so there is a kind of write-up on that exercise. Zach Molliker was the student who kind of drove that work. So he outputted a whole load of different possible geometries that went through a cycle with the engineer of trying to find which ones were working best from their perspective, and then I think it was 9-1F, one of these ones kind of became the preferred one. And there's some very specific conditions, the sort of the bits where the legs kind of meet had a very particular geometric need that pieces would match in a certain way. So getting all of those things to fit with these kind of varying pieces of wood was an interesting exercise, but the underlying geometry was maintained structurally. Those reference points were kind of kept, so they were always kind of brought with the piece of wood in the digital arrangement. So we kind of had a defined local axis that we knew for each piece. And then it was actually quite a simple exercise to kind of define connection interfaces between each element. So kind of at the node where the center line would hit that target, the target curve, we'd define a point in space which is where the pieces would sort of normally meet. There'd be a plane defined normal to that curve, which would be the compression face to face along the truss. Sort of similarly where the top chords met. So you could, just from kind of probably not that, I can't remember, but maybe like a couple of hundred bits of node information, you could then build back the connection geometry information. So I guess that's the kind of underlying connection points and plane sort of the blue circles kind of defining the connection planes where pieces would meet. And then they could be fairly simply extruded and kind of worked with to give the subtractive volumes that the robot would then cut to make the connections. So that's sort of that step, I suppose, to kind of turn those into little volumes of space. I guess there's a few tricks can kind of talk about. So there's a few different connections. I mean, there's a sort of engineering discussion about how these things worked out. So along the chords, a kind of face-to-face thing with a split ring, a little shear key that would hold them together, and then a probably more interesting kind of sort of distorted kind of elliptical mortise and tenon where the web member, so the tip of the branching piece would hit the top chord. So that kind of had, the top chord would have a kind of mortise, a hole to accept that shape. So there was the skilled manual carpenter's version on the left and the kind of robot version on the right, which you can kind of see the sort of the optimization into tool paths kind of in there. I guess the critical thing was to maintain sort of this face here as a good solid face, because that was where the actual bearing was happening. The stepped surface was more just a kind of location geometry. So this is Pradeep and Sweta, who kind of between them programmed the robot and developed all of those connection geometry, so output all that work. You've seen the video, so working with the router head, fairly simple operations, just kind of working on those faces, making these shapes. I guess there's a kind of few things to kind of clarify or point out. I suppose one was the critical thing was the relative positions of these connections. So the scan itself, like I said, it's pretty plus or minus 20 mil accurate, not that accurate, but we could, with the robot, mill within a couple of millimeters relative position. So the true position of the wood wasn't that critical within a certain range, but getting the relative positions precisely cut was. And I guess that's something which, without that kind of tooling and workflow, you wouldn't really be able to replicate. Like, we work quite closely with traditional timber framers, and when they saw what we were doing, they were like, "That is not buildable," for a long time. And then they kind of come back and, "Oh yeah, we could have built that," I think, but I guess given enough time, you'd work it out. But to try and sort of manually work out a way of referencing geometrically what you were doing three-dimensionally on a piece of wood, that would just be a nightmare, Whereas with this kind of tooling, you can just, as long as you kind of reference things correctly and kind of work it out, then you know that these pieces are going to fit. So there's things like you didn't know quite the diameter of the wood actually shrinks, since we scanned it. So you just deliberately kind of oversize the volume that you're machining. You accept you're machining some air, but you know that you're going to hit the piece of wood and get a detail that works. And so the detailing strategy being the same with this one. You route some air and you kind of dig into the wood. It doesn't really matter. You kind of, you machine a virtual volume that's a bit bigger than the piece of wood. Other little things to pick out. So the three holes that I was describing early on as the reference holes became the mounting holes on the sort of trolley. The thing that's holding the piece up. So that those three bits of threaded bar are sitting in the holes that we drilled initially to kind of reference things in the scan. Some of the bits we had to flip, so we'd get the robot to drill 3 new reference holes on the other side, and then they would become the support the other way up. So quite easy to solve that one. Not the best image, but the truss was pre-assembled in 2 halves, and then there was 4 what we call tripods, kind of inverted tripods that formed the legs that came down to the ground that were produced without the robot. There's a whole other story in those. The assembly was kind of interesting. So again, those 3-point reference points became useful. I think sometimes we actually drilled another set of 3 points, at a slightly different angle to accept these supports. So CNC cut the OSB floor to get everything in the right place, set up these props, and then use those as a kind of assembly jig for the whole of the truss. So then with the telehandler lowering in the fork pieces, they've been machined. You can see the split ring there. We actually ran I think the robot drilled a pilot hole for some bolts that ran through as a kind of tension tie just to hold things together. So one by one, these pieces being lowered in and fitted together and bolted up. Quite a hairy exercise. I mean, there's again quite a lot of physical, manual intervention, working with big sledgehammers, trying to get the thing to come together and join up. But amazingly, it all fitted. I think the first one probably took, I think it was maybe 3 weeks to put together, quite an exercise, and the second half was done much more quickly, within a week or so. And then the assembled piece, lifted out, taken out. Is that a video? No, is it? There is a sequence of the thing coming together, and that's it. But anyway, you get the idea. So yeah, telehandler carrying the thing out. A crane just for a day hired to lift the pieces in. Lots of crossed fingers and hoping these things would fit. I mean, obviously we hadn't pre-assembled the whole arch, and we'd already cast the abutment, so things kind of had to fit. So there's a little bit of deliberately making it a bit high, just leaving a little gap, and then kind of winding down the props off the scaffolding and everything fitting and going to the pub happy. And then this object sort of emerging, once the scaffolding was taken out. So something kind of interesting about it, something nice about it without the rest of the building around it. This kind of curious object in space anyway. The rest of the building happened as well, so the walls and the roof is obviously an exercise in itself, kind of procuring all that and getting that together. And the final thing as it stands there. 2 more pictures, so kind of sense of the interior space with the roof on. And I think the last slide, that image again, just looking up at the pieces in the roof. That's kind of it. Thank you. The websites.
If anybody has any questions, we could probably take a couple.
Good question. Did everyone hear that? I think it was about whether we treat the wood. Was that right? So we do. We have to be really careful, particularly in the English climate. The different species all behave very differently. So some of the wood you can just leave outside. Some of it will only last a few years. The beech is somewhere between the two, I guess. We treated it with boron salts, which deter the sort of parasites and the fungus that attacks that wood. But it is a big issue, and we still, I think, will need to do something to cut those tripod pieces sit outside of the shelter, and I think they will need some better protection, in the next couple of years to give it the kind of life that we want to give it. But yeah, the way that working with, it's a natural material that obviously naturally decays. How you deal with that. We try and resist using too many kind of nasty chemicals, and you can basically poison things if you want to kind of preserve the wood. But I guess strategies of kind of detailing things carefully, like on that on the boiler house building with the stacked logs, there's a series of details in there, just in the cross section. I didn't talk about it, but we were cutting alongside cutting the sort of top and bottom with that chainsaw. We were also running somewhere on the back, somewhere carefully anyway, placed a slot that would control where the split would happen. Often you get radial splits on these pieces of wood as they dry out. So basically making sure that the split would happen where the rain wouldn't get in, and also cutting in a little drip detail to kind of keep the water away from the next piece. So if you kind of anticipate some of that stuff, you can help give some life to the wood,
Yes. In as much as everything you're sort of showing is build and so forth, the process of wood, is there anybody working with sort of the living wood, bleaching, grafting techniques, things like that? David Nash, his work?
Yeah, absolutely. Yeah. David Nash does this amazing kind of 20-year sculptures, doesn't he, where he works with that. And I think there's a few people around. I think there's someone in the east of England who's growing chairs. I guess there's the Bautechnik group in Stuttgart who are doing kind of larger sort of scaffolded growing trees that then form their connections. It is a topic that we're fascinated in. There was actually one of our current MSc students, Laura, who kind of interesting. She's a sort of artist turned carpenter with exactly that kind of fascination. So she's been looking at how kind of foreign objects influence growth patterns. So you can actually kind of persuade growth to kind of encompass something else. So she's been kind of looking at that and she's designed a new gate that's going to be ready in 20 years' time and things like that. So yeah, it's a really fascinating aspect, I guess, that time dimension of the tree. And I think it sort of reflects as well. I mean, we were just discussing earlier kind of the forestry of the woodland, which to have that in the background is kind of interesting. The forester has a very different conception of time, I suppose. That you're designing. He's the designer. He's designing that landscape, but and a product that's going to be beyond his own lifespan. And I think to kind of expose architecture students to that is kind of interesting. You could probably think of a building in a similar way, but we tend to think of the opening day as being the moment to worry about. And I don't know, there's aspects of the time dimension of working with wood that is really interesting.
Structurally too.
And structurally, yeah. I mean, if you could, I mean, using the shrinkage to your advantage, or I suppose that idea of using the fork and the strength of that, you could actually kind of control. You could anticipate, I suppose, couldn't you? And because the tree grows to respond to the forces that are applied to it, you could actually kind of anticipate, optimize the joint in its growth or something. Anyway, yeah, fascinating set of possibilities.
I have a question. For the students, if our students were to come to your MArch program after their 5-year degree, do the students that you're getting come with expertise in robotics and making already, or you have other courses that bring them up to speed on?
Yeah, generally not. I mean, obviously, I suppose globally there are more programs like yours that are starting to introduce students to that work, but the first term is basically dedicated to a kind of largely a skill building exercise, so taking through all the fundamentals, right from kind of working, scripting, Grasshopper, fundamentals of what Rhino is actually doing and how to kind of extract that information through the digital workflows and through that. And the same with the workshop as well. I mean, some students come with a background that gives them a confidence in the workshop and some don't, and we try and make sure that people who don't have that background kind of gain enough exposure to the tools and build it up. So the short answer is we don't require any of that kind of background. I mean, I think what our, certainly for the MArch program, it's students who've done conventional architecture studies. So I guess the idea is that they're coming in as kind of basically young architects, so that they're able to understand the architectural process. So obviously we work through a design exercise, but the making ingredients is what we're able to kind of add into that.
Okay, thank you very much.
There's one more.
Sorry.
Yeah, so I think there's still debate about what actually goes on when you steam it, but there's parts of the makeup of the cell of the wood. There's like lignin, I think, is the key material that sort of like a kind of plastic that you can heat up and deform, and then it sets. It's whatever it is, thermoplastic, I guess. The lignin kind of behaves in that way, I think. So you can, if you heat it to 100 degrees, it allows things to be deformed, and then when it cools back down, it stays in that position. You always get a bit of spring back, and there's quite a lot of subtleties about how you kind of control that. We have a student at the moment actually who's exploring fire bending as a technique, so it's kind of dry steam bending, I suppose. And there's another sort of set of things that happen there, where you're actually charring the wood and the structure kind of breaks down a bit differently, but you can also impose a permanent change in shape in the wood. So yeah, I think there's quite a lot of, there are pockets of technical research that are trying to answer that question in more detail at the moment.
Good. Okay.
We're done.
Thank you very much.
Great, thank you.
Boggles my mind.
No, it's fun to present. I took a little bit longer to kind of get to the bit that you introduced.
Great workshop. Thank you so much.
Thank you.
I didn't know you didn't talk about the fry order aspect of it in Vienna. So that's
No, maybe
the
mention
whole
that. Yeah,
background and the idea also that oddity of standardization in order to get non-standard things. That's really fascinating.
See, it's like a stone brick, right? Do you
Yeah.
ever use that?
Yeah, I should have. I think of that question. Yeah, there's a kind of broader way of
It's almost
using
like a
that idea.
sustainability question,
Yeah,
right?
yeah. I think almost in a kind of recycling. You can imagine kind of taking broken down, or half broken down building material and reuse it.
A lot of the units in the undergraduate program, they use the park.
Yeah, it's up to the tutors. So
Like Shane will come
Shin
over.
comes. Yeah, we have to kind of hold Shin back a bit and get some other people in.
Weird Japanese guy I used to teach with, but he does smaller scale, right?
Yeah,
It's
so
like a studio.
So with the studio, they come and model make mainly.
Yeah, using wood.
Using wood a lot and just
A lot,
that space and kind of casting and doing crazy Shin stuff is always
Yeah,
fun when they're there. He's been doing this Mighty the Corp for kind of sponsoring a series of workshops. He's been doing it at a kind of furniture into kind of landscape scale. So series of pieces that he's done do that, which are little short courses.
So you always support these studios,
Yeah, so
small projects.
So we kind of host, and it's based. I guess the model is that just units can book a slot, and their tutors come and they kind of
come
define.
over
They,
for a day or
tends to be kind of
Weekend.
long weekends, 4
That's
days
right.
up, and shouldn't have to come maybe for 2 weeks at a time. But we kind of, the idea I guess is the tutor kind of brings their
That's right.
agenda and what they want to do, and they'll kind of talk through with the workshop manager or me or Forrester if they want to do something specific and line things up.
But you mainly run the master's program.
Yeah.
That's the main,
Yeah, so I guess my job is kind of split between the actual kind of academic side of running that program, and then I guess it kind of merges with generally directing Hooke Park, which I suppose is there's quite a few parallel things with the program. We're doing a few kind of off-site, small kind of scale community engaged projects, but expecting that aspect to grow, I suppose, as our
As you build
As
out
we-
your
yeah, as
campus,
we-
right? You need other spot.
Some kind of revenues.
well, potentially, I suppose. I mean, I guess that's more just anticipating a model where we're not building our own buildings, but
Yes.
having to have it, having a different client. And then, I don't know, I suppose there's other kind of agendas, there's a bit of discussion about sort of how we fit into kind of, there's a few people around talking about rural housing and
Okay.
ways of kind of developing that in kind of the English kind of context, I suppose. So there's a few organisations around us that generally working with. There's some, I mean, you could do it very different. You could present it very, very differently, I suppose, what we're doing there. There's some quite nice potential collaborators or people we're kind of working with a little bit. There's a boat building school, like readers who are amazing, like they do kind of similar. They do like a 12-month design for the boat kind of process.
That's cool.
With the traditional techniques in there, so we kind of exchange with them a bit. They come and
See what you're doing.
What happens with the new director now? Because
yeah, so that's
still,
Yeah, so he's-
well, he's moving
I'm gonna
to.
just run the restroom. I'll be right back.
yeah.
He's moving. He's still there.
No, he kind of packed up in July, I
I
think.
know.
So
Yeah.
I don't know when his job actually starts in LA.
Because he
but-
was here, we were talking about it, and then last semester, and then a few weeks later, it was announced that
Right,
he's
okay, yeah,
leaving.
yeah.
And I know I've
Yeah.
been to the AAA many years to know how this process of,
yeah.
it's kind of the whole community votes and so
Yeah.
on, which
Yeah, so
can be
that's-
political or difficult sometimes.
Yeah, I mean, there was the search committee that was voted for,
Okay, there's a
Um,
search committee now.
which
yes.
includes Chin actually, and a few other people. So
Yes.
that was sort of set up,
Yes.
I guess in the springtime, maybe March or so. I think they've been working through quite a bit of kind of consulting everybody, kind of make sure that
Yes.
voices in there, and they're writing up job description, I suppose, and
Yes, yeah,
getting
yes.
an advert out.
And
I
they
think
haven't.
very soon.
Okay, they
It
are.
hasn't been advertised
Okay,
yet.
so this year, so this academic year,
So there's an interim.
Who is the interim?
Samantha Harding.
of course, she was my student.
Was she? Oh, very well done.
She was my student the first year. I used to do the studio with Carlos Villanueva.
Okay.
He's still there?
Yeah, yeah,
Carlos,
he's there, yeah.
And Tommy Hennigan.
Right, yeah, I
Tom, you
don't
may-
know him so well, but yeah,
He
Carlos
left.
is still there.
Yeah, and Samantha. Oh yeah, and Samantha had a studio, a unit with the Archigram.
With David Green.
David Green,
Yeah, yeah.
amazing
They do.
personality.
Yeah, he's
I don't know if he's still there.
Yeah,
He's still.
he's got a little kind of role of kind of just making people to kind of talk to each other.
Yeah,
and just
yes,
kind of
yeah, that's right. Yeah.
probing and pushing
Yeah,
a bit.
yeah. And he was helping Sheen a little bit, and then Sama. I think he did
They
his.
were teaching first year together, I think.
That's right. Oh,
So Sam's been doing an intermediate unit, and then
that's right.
I guess she was sort of sharing the undergraduate management committee, so she was kind of, I think she's been quite involved in the degree awarding powers
Okay.
process, which is
Yes.
underway.
Yes.
So it kind of made sense, you know, safe pair of hands. She knows what she's doing and knows the school well.
That's
she's,
right,
She's
yeah.
great, you know, she's
Yeah.
perfect for that job.
That's
so,
right. Yeah. That's good. I
And
hope
she's been
so.
down to Hook already and,
Yes.
you know, getting involved in
Yes.
what we're doing.
So
So
hopefully they get some good candidates for
Yeah.
the shortlisted, shortlist
Yeah.
presentation.
yeah, no, it's exciting. I
Yes.
think,
The school is doing well.
I mean, Brad did a good job, and like, he'll be missed, but at the same time, there was
Yeah.
12 years of.
Yeah, he's been
this thing.
for a while. Yeah.
So I think it'll be healthy to,
Yes.
be good for the school to
Yeah. I
have
think
someone
so.
in and
I
bring a
think
new,
so. Yes.
bit of thinking in there. It's interesting. It's all, I guess. I think with the degree awarding powers thing is kind of forcing a fair bit of kind of reflection as well, and
Yes.
kind of imposing. He's been kind of forced to be a bit more